All right, welcome back. This is Steve Scully, and I am reading from my book, The Instruction Manual as It Is Written in the Cosmos, and we're on Chapter 3, The Structures of Infinity. Section A, Structures of the Universe. The universe is a mind-boggling place, yet it has patterns that reveal its true nature. These patterns carry weight that is not incorporated in standard models, leaving us to wonder at the apparent illogical, inexplicable nature of reality. If we follow the patterns, though, the mystery of the universe reveals themselves. If we strip away all of the complexities of what we think we know and peel back the layers to reveal the foundational underbelly, what we can initially say with certainty is much less descriptive than what we claim to be able to say with certainty. For example, what we call atoms have extensive descriptions that elaborately attempt to explain a full range of details about these observed components of the universe, from the nuclei constituents to the quote charge of the atom's particles. Everything we claim to know of the particulars of these structures is built on sweeping, universally applicable approximations. Even the very claim that there are hydrogen atoms or helium atoms or any particular element of the periodic table is built on assumptions. Assumptions that these systems, which share apparent similarities so great that we cannot distinguish their differences, actually are identical. In truth, what we can say with certainty about these systems is much less and far more generic. Regarding atoms, the following are known characteristics. 1. They have a central mass portion, and 2. They have an orbiting mass portion. Any further details are too descriptive and carry assumptions with them, some of which can easily lead into subsequent assumptions. To even call the central mass a nucleus leads to a wide array of additional details about nuclei that are built on inference and assumptions. Similarly, to call the orbiting mass portion electrons instills an unconscious assumption of supposed charge properties to the particles. It is important to recognize that just because something behaves a certain way in a certain environment does not mean that that behavior is an intrinsic characteristic of the system. Charge is not something that just exists. The observations that we call charge have an actual explanation beyond the labels, which we will discuss. These systems are so difficult to observe that we cannot reliably claim to know with certainty anything else about their characteristics from exclusively studying atoms. Everything else we know about them is conjecture. In order for proper understanding to arise, it is necessary to strip away the complexities of hypotheses and get to the root of what is fundamentally known. We can clearly see that atoms have specific masses where they tend to exist. This would suggest that we can therefore say that groups of identical systems exist at distinct weights that we can then label with names. However, at its core, this only indicates that there is a trend. If we exclude variation from an exact trend, we inadvertently assume that the trend is absolute. Rather, this trend suggests only that there are stability points where systems find balance that they tend to be in or very near. Atoms are small, at least from our perspective, and so we do not generally experiment and deduce details about these systems individually, but rather through measurements of many systems simultaneously. This leads to a process of grouping all those that are so observably similar to one another into larger groups, which we then obtain an average weight thereof and hold it as exact. If 100 people who all weigh approximately the same are weighed, their average weight will be very close to each individual's weight. This does not mean that these people are all identical. Instead, elements of the periodic table consist of groups of very similar systems which are so close to each other in properties that we approximate them to actually be identical. The same can be said of electrons. All we can really say is that there are trends of balance and stability where systems tend towards. We cannot say that identical systems exist. We need only look at what we can observe most directly to recognize this. Larger systems such as stars, planets, and moons all are recognizably different from one another. If we look at any other system we can directly observe in the cosmos, none exhibit this sameness that we attribute to the particles we cannot look at. No one would suggest that because a star has approximately the same characteristics as another star, that they are identical. Recognizably, they would be two systems having varying arrangements of the many particles which make them up. However, their nearly identical characteristics would make it clear that they behave very similarly. The distinction would remain that they are not identical, but rather are very similar. The same can be said of atoms. Just because we cannot directly observe atoms does not mean that the systems suddenly are identical. This is a common mistake in the study of particles, to disregard the uniqueness of the systems we can directly see when analyzing those we cannot. From a logical standpoint, this requires a fundamental differentiation between how systems function at our scale versus how they function at the small scale. As a result, it does not pass the sharpness test due to requiring this differentiation. Thus, caution regarding claims that systems are the same is necessary. The same can be said regarding the existence of, quote, protons and neutrons. While there are distinct trends that occur, the interpretation of the existence of these nuclei constituents and their constituents in quantum mechanics suggests there are functionally different and simpler elementary particles on the small scale than what we can directly observe. It is for this very reason that a ground-up approach of starting from what we can see is important. When we look at planets and stars, we see single spherical bodies. We do not see any conglomeration of, say, 50 identical particles which make up a single planet or star. This goes against all logic and reason, and yet this is precisely how we envision the nucleus of an atom. This differentiation between the nucleus of an atom and the makeup of a planet or star is a more complicated description than one where each system functions mechanically the same. In other words, the nucleus of all atoms is a single system. It is not composed of actual particles called protons and neutrons in some sort of conglomeration. There is no increased complexity in the general behavior of particles as they get smaller. To delve into protons and electrons further, it is necessary to review the history of how each came to be considered to function as described. The word electron is derived from the Greek word for amber. In 1600, the word electricus was coined by William Gilbert, later developing into the words electric and electricity. In 1733, C.F. Dufay proposed a two-fluid theory where electricity comes in two varieties that cancel each other out. When glass is rubbed with silk, according to Dufay, the glass was charged with vitreous electricity, while the silk was charged with resinous electricity. Similarly, when amber was rubbed with fur, the amber was charged with resinous electricity, and the fur was charged with vitreous electricity. In 1839, Michael Faraday showed that static electricity, current electricity, and bioelectricity were all a result of the behavior of a single kind of electricity appearing in opposite polarities. It is arbitrary which polarity is called positive and which is called negative. This is a subtle clue into the nature of charge, as these labels only carry with them recognition of a polarity rather than what has come to be called charge. James Clerk Maxwell, in a treatise on electricity and magnetism, showed that when a piece of glass and a piece of resin are rubbed together and left in contact, they exhibit no electrical properties. It is only when they are separated that they attract each other. By rubbing a second piece of glass with a second piece of resin, it can further be shown that the two pieces of glass repel each other, and two pieces of resin repel each other, and each piece of glass attracts each piece of resin. Any body that then repels the glass and attracts the resin was said to be vitreously electrified. Alternatively, if it attracts the glass and repels the resin, then it is said to be resinously electrified. All electrified bodies are one of these forms. An established convention in the scientific community defines vitreous electrification as positive and resinous electrification as negative. The exactly opposite properties of these two kinds of electrification are the basis for the opposite signs, but the assignment of each is considered a matter of arbitrary convention. This means that the main reason we have come to look at electrons as having negative charge is because they tend to flow in this manner relative to their environment. This is the basis for why electrons are said to be negative in charge. With regard to the history of protons, in 1815, William Prout proposed that all atoms are composed of hydrogen atoms, based on interpretation of early values of atomic weights. Ernest Rutherford discovered the atomic nucleus in 1911. In 1917, he went on to conclude that the hydrogen nucleus is present in other nuclei, a result described as the discovery of protons. Through radiating nitrogen gas with alpha particles consisting of helium nuclei without its electrons, he recognized signatures of typical hydrogen nuclei as a product. He found that when alpha particles were introduced into nitrogen gas, it produced oxygen-17 and hydrogen nuclei. Due to this result, Rutherford concluded that hydrogen was the building block of all elements, describing the hydrogen nucleus as being present in all other nuclei as an elementary particle. This led to the hydrogen nucleus being assigned the name of proton. However, just because a hydrogen nuclei is produced does not mean it was physically in existence as an individual component of the nucleus prior. This does not preclude a system, when sufficiently energized, from reacting to the energy to enter a new stable state by producing a hydrogen nucleus, however. In other words, it does not inherently mean that the hydrogen nucleus was present in the parent atom's nucleus. Once more, this is a result of how these particles tend to behave relative to their environment. Of critical importance to note is that the free proton, having no electrons, is able to be stable under certain conditions, meaning it is stable without an electron to, quote, balance its charge. In particular, free protons exist in plasmas in which temperatures are high. This shows an important clue in the understanding of how these systems function, since they do not always behave as having a charge. This environment dependent characteristic indicates that what we consider to be a positive charge is only such when it is in the environment where we see it as behaving as a vitreously electrified system. We will return to charge to discuss what causes this observation in a moment. First, to better understand how atoms function, it is important to step away from atoms and compare systems of all masses to recognize shared characteristics. This process enables recognition that all systems function the same. From a sharpness factor standpoint, this is supported by its simplicity because it is the least complex description possible. Models are more complex when they suggest that the behavior of systems that we see differently is different, requiring individualized descriptions of each rather than a blanket explanation of all. This is alike to claiming that each planet follows its own laws rather than all functioning under the same universal laws. The best way we see the shared functions is to look at larger systems because we can see them in more detail. Therefore, planetary systems are now considered. When we look at planets, immediately we see that in large objects there is no apparent identicalness. This confirms that individual atoms are also not identical to one another. Using the same process of removing all descriptions beyond the most generic descriptions of these systems, we can say that planetary systems have they have a central mass portion, and two, they have an orbiting mass portion. For a planetary system, the central mass portion is the planet itself. The orbiting mass portion comprises moons, planetary rings, electron belts such as the inner and outer Van Allen belts. These generic features seem to repeat themselves. This repetition of features across a wide array of systems is recognizably a pattern. From a logical standpoint, patterns are vital to recognize because they allow us to extend our understanding of the behavior of systems we see in certain ways to other systems we cannot see in the same way. This functions as a process of ironing out the details, where each system can be better understood by extrapolating from those we can see in specific environments. With solar systems, the same pattern emerges. One, they have a central mass portion, and two, they have an orbiting mass portion. In a solar system, the central mass portion is the star, while the orbiting mass portion comprises the planets and the belt systems such as the asteroid belt and the Kuiper belt. Then for galaxies, again the same pattern emerges, where one, they have a central mass portion, and two, they have an orbiting mass portion. In galaxies, the central mass portion is the supermassive black hole, and the orbiting mass portion comprises the disk of the galaxy. With galaxies, due to their high mass and slow functionality from our perspective, additional features can be distinguished. For example, galaxies can have, quote, spiral arm structures, as shown in figure 12 below. Notably, not all galaxies have this structure, and so to consider the cause of spiral arms, we can look to another system for explanation. This is a perfect example of doing so to iron out the details of the mechanics behind an observation. Referring to the solar system, the sun's rotation causes its electromagnetic field to rotate, and this leads to what is known as the heliospheric current sheet. The sheet acts to separate regions of solar wind, discovered by Dr. John M. Wilcox, who first published the image of figure 13 in 1980 in Science. The structure of the heliospheric current sheet was based on observations of solar wind and the corona and coronal field models. So just to compare real quick, they are the same structure in essence, because it's the same mechanism behind it. Okay. Due to each unique and distinct system operating by the same underlying principles of the cosmos, so too does the creation of the spiral arm structure in a galaxy occur by the rotation of its central mass and its electromagnetic field. In this simple example, we can see how limiting our description of what is actually known as conservatively as possible produces the outcome of a much more precise interpretation that we can hold firmly to be accurate, that spiral arms of galactic structures form due to the rotation and electromagnetic field of the central mass object. This is not the current theory. Instead, the spiral arms of galaxies are attributed to the rotation of the disk structure rather than the central mass. While this is a nuance, there is no recognition of the actual rotation of the central object itself. This drastically limits our ability to understand the underlying fundamental causes of these observed interactions, because we see them so differently that we do not look to a wide range of observations to decipher what is occurring in individual systems. Galaxies are only analyzed with respect to other galaxies, solar systems only with respect to other solar systems, planets with respect to other planets, atoms with respect to other atoms. This limits our capacity to decipher how reality is, because we are not inferring from systems that appear different, unnecessarily limiting the range of observations that can assist in deducing the nature of each particular system. It is thought, quote, atoms are not planetary systems, are not solar systems, are not galaxies, end quote. And yet they are. Large-scale variations in steady states produce an apparent classification and categorization between observed systems as belonging to our particles labeled group: atoms, planetary systems, solar systems, and galaxies. This leads to interpreting each as separate from the others. Atoms are atoms and are analyzed as atoms without consideration for the functionality of other systems. The analysis becomes so microscopic, boxed in and approximated that it no longer describes reality, and it instead represents but a faint shadow of what exists. We are able to cross systems that appear differently because the universe is infinite. If each particle in the infinite structure of larger and smaller particles functioned differently, the complexity would be infinite and the sharpness of the model would be as dull as possible. When all systems are seen to have the same underlying mechanics, then the sharpness is as sharp as possible, having only one unified explanation for all, and thereby an infinite weight and density behind it. If galaxies and solar system have a moving electromagnetic field that causes disturbances to their surrounding orbiting mass, what does this tell us about rotating planets and atoms? Through cautious pattern inference, concrete conclusions can be made about systems other than those being analyzed with confidence. This is done by repetitively considering observations in each classification of particles and inferring what it tells us about the functionality of other systems. As a result, what we can say with certainty is able to become much more descriptive and absolute than what we were claiming to be able to say with certainty. Truth only reveals itself when each system is seen to be unique, different, and distinct, and yet to function by the same underlying principles as all other systems. In the case of a rotating planet having an electromagnetic field such as Earth, this pattern inference process indicates that the Van Allen belts are manipulated by the quote geospheric current sheet of Earth to function as a spiral disk structure. This is because the Van Allen belts of Earth, the asteroid and Kuiper belts of the solar system, and the disk of a galaxy are analogous, though we see each differently as a result of using specifically the particles that we call atoms to observe each. Their function is the same. It is the relative mass of the components of each system compared to the atoms which we use to observe them that dictates how we see a given system. It is not that each is intrinsically as we see them, but rather due to the ratio of the mass of our largest building blocks that we use to observe every system to the mass of the observed system that determines how we see each. In other words, our solar system is a galaxy. We are composed of atoms, and we see our solar system as we do. This does not mean that all life in the universe is specifically composed of the building block that we call atoms, but rather an observer can be composed of any of the infinitely larger or smaller building blocks. In this way, the universe is fractal in nature, an observer composed of building blocks smaller than our atoms, particles having the same mass ratio to our solar system as our atoms to the mass of a galaxy, would observe our solar system as a galaxy. Relative to the Kuiper belt, the asteroid belt and planets are close to the sun and compose only a small portion of the volume of the solar system. What we call the Kuiper belt would be observed directly as the disk of the galaxy that is our solar system to this smaller observer. Moreover, due to the heliospheric current sheet, it would be seen as a spiral galaxy. Much the same, an even smaller building block observer would look to our planetary system as a galaxy, seeing it as such when they have a similar mass ratio of their building block to our planetary system as the mass ratio of our atoms to what we see as a galaxy. This raises many questions regarding the nature of what we call black holes, which we will revisit soon. It is important to note that if this is the case, then we would be able to see that the sun and the earth function the same because each are the general central object. In fact, if the universe is infinite, then all central objects must function the same. A very similar process can be conducted to determine whether or not there are parallels between the systems that indicate if this is the case. So I'm going to stop here in this video, and I'll continue on in the next one. This one's running a little long. So thanks for listening, and I'll be back in the next video with the rest of this section. Thanks.